In exercise number 6, we're given something that looks sort of like a magic square. I don't know if any of you have done magic squares before, but you try to place numbers so that the rows and the columns all add up to the same number, as well as the diagonals. So, so let's take a look at this and see if we can solve it. You may be wondering why I included this problem in the lesson on arithmetic series and sequences. And the reason is that we can use the things that we've learned to help us solve this. So let's take a look at this. We're given that the odd integers from 1 to 17 are placed in the grid so that the sum of the numbers in each row, column, and diagonal are the same. And the question asks, what does the number x represent? And the way that we can use series and sequence, the things that we learned, is that we know that the sum of each row and column has to be the same, but it doesn't say what that sum is. So if we were to sum up all the odd integers from 1 to 17 and divide it by 3, because we know we had to place all those integers in a cell somewhere. So if we divide it by 3, so that'd be like all the rows or all the columns, then we should get the sum of what one row or column should be. So let's do that. So we're looking for the sum of the odd integers. So we have 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13 plus 15 plus 17. Now I probably didn't need to write them all out, but I thought I'd just go ahead and do that. And we know that the sum of that has to be the first number plus the last number times the number of numbers. How many we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 of them. And we divide that by 2. And so we'll get 18 divided by 2 is 9. So 9 times 9 is 81. So now we know that the sum of all the numbers in the grid has to be 81. And if we want to know what the sum of any one row or column has to be, then we can divide 81 by 3. And we'll get, let's see, 27. Okay? So now we know that all the rows and columns have to add up to 27. So we can, like here we have in this column we have 5 and 13, which adds up to 18. So to make that column add up to 27, we know that this number has to be a 9. Okay? Now I am going to here we have I listed all these out for a reason, and that was because I wanted to be able to mark off the numbers that we've already used. So we've used 1, we've used 5, we've used 13, and now we've used 9. So let's take a look at what we have left. We want this column to add up to 27. We've got a 1, so it needs to add up to 26. Now how can we make 26 with the numbers that are left? So if we were to take 17, we'd have to have add 9 to it to get 26. And we've already used 9, so we can't use 9 again. If we had 15, we could add 11 to it, so that'll work. So I'm going to write that down. 15 plus 11. And will any of the other ones work? 11, 15, 7. We'd have to add what 19 to it, which we don't have that number in the list. So it looks like the only possibility is 11 and 15, but we don't know which goes where. So let's take a look at this row down here. And we have 13. If we subtract that from 27, we get 14. So the two empty spaces have to add up to 14. Well, I know 17 and 15 can't go anywhere. 11 plus 3 would work. And 7's not going to work because that would take another 7. So this has to be 11 plus 3. And you notice that this corner here has to be common between this sum and this sum, so this has to be 11. So then that has to be 15, and this has to be 3. And now, now that we have some numbers in here that, so we know like this 15 plus 5 plus x has to add up to 27, so we know that x is equal to 7. Alright? Same way here, we got 11 plus 9 plus 7 would be 27. And we can also figure out what this number has to be. And the only one left, really, we've used 15, we've used 3, and we've used 11. We said x was 7, so the only one we have left is 17, and 3 plus 17 plus 7 is 27. So, the main point of this, of including this problem with the arithmetic series and sequences is that we can use our formula for the sum of an arithmetic sequence in order to find out the total of all the numbers and divide that by however many rows and columns there are, and that'll help us figure out this problem. So, but the answer to this is x equals 7.